Okay, yesterday we talked about naming ionic binary compounds. So if you have your notebook, you should have a list of all of the anions made from elements like sulfide, oxide, chloride. So it was pretty easy because we said, hey, the metal doesn't change its name. So if I have something like sodium and I put a Br there, the only thing that we have to remember is this has a +1 charge, that has a -1 charge, so those charges cancel out. And if it helps you, you can always write it somewhere on the side and say, well, how many of each do I need? But the name for this is just sodium bromide. That's pretty easy. And if you do have ions with different charges, like let's say I've got a calcium and a Cl chloride. Well, this has a +2 charge, that has a -1 charge. So you have to say, well, I'm going to need two of these to cancel that -2 charge. So CaCl2. And we call that calcium chloride. Now, sometimes going from names to the formulas, that might be a little trickier. So if I say, write the formula for aluminum oxide. Well, remember, you have that list of all your charges on different ions. And you say, well, aluminum, I know that has a +3 charge because I have it written in my notes. And eventually you just learn this stuff. And oxide, I know that has a -2 charge because you have that in your notes. So what you can do is say, all right, what's the least common multiple of 3 and 2? It's 6. So I need 2 aluminums to give me +6 and 3 oxides to give me -6. So that's where we ended up yesterday, and it wasn't so bad. Now what we're going to do is look at the so-called transition metals. The transition metals are those metals that come from where it says 3 over to 12 on the periodic table. First of all, there are two transition metals that only get one charge, and you'll never have to worry about them. Zinc and silver. Zinc always gets +2, and silver is always a +1. So even if you want to write that in the block, +1 and +2, those never change. Now, other transition metals can get more than one charge. Some metals can get 3, 4 different charges on them, depending upon how many electrons they lose. So there are two. Let's look at iron, for example. Iron, you can have iron with a +2 charge, and sometimes iron gets a +3 charge, as do many of the transition metals. So if I write iron chloride, I have two different versions, FeCl2 and FeCl3. So we have to somehow, if I'm going to say, Sam, go get me the iron chloride, which one are you going to get me? Because you don't know. I didn't specify it. So the only difference when you're using transition metals is you have to write in parentheses. I'll go over here. Now, I know this is +2, so we have to indicate that in the name. So it's going to be iron, and all you have to do is put a 2 after it in Roman numerals. That means iron +2 chloride. Down here, iron +3 chloride. So that just refers back to the charge. That's all there is to it. So the only time you do this, though, is for those elements that get more than one charge. For example, if you have magnesium chloride, you just write magnesium chloride. You don't put parentheses there because everyone knows that magnesium only gets a +2 charge. So there aren't two different versions. So now I can say, Cameron, go back and get me the iron 2 chloride, and you'd know which one to get me. Connor, get me the iron 3 chloride. You'd know which one, FeCl3. Let's do a couple more of these. Now let's look at these. And we're going to go from a formula to a name. Well, manganese is a transition metal. It can get two different charges, a +2 or a +4. So how do I know which is which? Well, so how to determine the charge on the metal? Look in your notes and tell me what oxide charge is, or on your periodic table. -2, yeah. So you look at the anion. That's the negatively charged anion. So I've got one here, one oxide rather, so that has to be a -2. So what does the manganese have to be to cancel that? +2. Perfect. So I would call this manganese 2 oxide. Again, that 2 refers back to the charge on the metal. Now let's take a look at this. Cameron said that oxide has a -2 charge. That's correct. And I've got 2 of them. So what's my total negative charge? If I -4, right? Because I have 2 things with a -2 charge. Yeah. So altogether, I've got a -4 charges because I've got 2 oxides. So what does that have to be to cancel it? I want to cancel a -4, so what does that have to be? +4, yeah. So I'm going to call this manganese 4 oxide. Making sense? We'll do some more. There are 3 metals that are not transition metals that also have more than one charge. And I'll write those down. Let me get out of the way here so I can put that on video. And you can write it down. Okay, so always look at the anion. That's going to help you to determine the charge on the metal. 3 metals that you have to be, and you could take your periodic table, you can circle these. Number 50, Sn, tin. Number 51, this is tin. This is antimony. And this is lead. They can get more than one charge. Usually either +2 or +4. So these 3 metals, you're going to need parentheses for the names. So if you want to circle them, I said this is 50, this is 51, and lead is 82. Okay. So those are some exceptions. Okay, so let's see if I'm going to give you a couple. See if you can name them. Take a minute and see if you can come up with names. I'm going to pause the video. Okay, let's take a look. Even if you're not quite done with them, there's another way you could do this. If if you're having some trouble, remember, you know the charges that each of these ides get. Chloride is -1, oxide's -2, fluoride is -1. You have that in your notes, and you have it on your periodic table. So you could even do this like an algebra problem, like 2 times -1 plus x has to equal 0. Well, this is -2 plus x equals 0. So x is going to be equal to +2. That's how you would do it. And then you could just put tin 2 chloride. That's another way you can do it. Or you can just think about it in your head. Whatever works for you. I don't care. So this one, well, oxide, that's a -2 plus x, I only have one of them, is equal to 0. Well, then lead's going to be +2 again. Lead 2 oxide. And over here, if you want to do it this way, I've got 4 times -1, because you know fluoride always has a -1 charge, plus x equals 0. You can go ahead and solve for that, and you get a 4 here. Antimony 4 fluoride. And remember, this, wrong arrow. This Roman numeral goes back, and that means the charge on the metal. Not too hard, is it?
Wait, for this second one, there's no number on it. So
Here? If there's no number, they're ones.
Oh, okay.
Yeah, I should have mentioned that.
Wait, but where did the -2 come?
Oxide. Look in your notes, oxide should be -2. Yep. So -2, I only have one of them. Remember, if there's no number, it means 1. So I have 1 times -2 plus 1 times x is going to give us 0 in that case. Yeah, we'll practice.
But like for the last one, like that one, you don't do that for the SP. You don't look for that charge, or no?
Well, the way you find that charge is by looking at how many anions you have.
Okay.
Because we don't know the charges unless we can figure it out by looking at the
So
anions.
if they don't give you a charge, you have to look.
Right. Now, if we go the other way around, if I write the name and I ask you for a formula, it's even easier. So let me do a couple like that. Let's do a couple. I'll give you a name. So right away, when you see cobalt-3 bromide, that 3 means what? That means the charge on the metal, +3. So cobalt has a +3 because it tells us right in the name. Bromide, if you look in your notes, is a -1. So how can we write the formula? Well, how many of these do I need? Got to cancel a +3, so I need how many of those? 3. COBr3. There's your formula. I'll do another one. Iron 2 sulfide. So again, that goes back, and so I have iron, the +2. Sulfide, if you look at your notes or the periodic table, gets a -2. So this is a real easy one to write. FeS, 1 to 1. Get this in? Straightforward enough. All right, I'm going to challenge you a little bit. And again, this will all be on video too if you want to go back and watch it. How about I write this? Iron 3 sulfide. Okay, I'm going to pause the video. You try to come up with the the formula for that. With. Did you get it, Ashley? What'd you write? What's the formula? Fe plus 3. And what's the formula for sulfite? What? -2. So how do I put subscripts in here to make sure that all those things cancel out, those charges cancel? You got it. And if you want to, you can even do that little draw the arrow, just put those numbers down there. That's another way to figure it out. Good. I think that you're in pretty good shape with these sorts of things. So, I have a question for you. I don't want to write that. I want to write it in words. What's wrong with that name? Look at your periodic table. Look for potassium there. You tell me why that name is written incorrectly. Let me ask you this. What charge does potassium get? Does it get any other charge at all? No. So if a metal only gets one charge, you don't have to say it because it's redundant at that point. It's just potassium chloride. You can't go back and find two different versions of potassium chloride. How about, well, any of these. Like if I put calcium 2 oxide, that's wrong too, because calcium only gets a +2. So we don't have to say it. So I guess if we summarize things up, for ions, I should say cations, that can get more than one charge, you have to indicate the charge in parentheses using Roman numerals. In the written name. So that's bullet point 1. Bullet point 2, to determine the charge in parentheses look at the anions. The cation charge must cancel the charges of the anions. Sorry about my handwriting, it's a little sloppy. But I'll read it to you again. For cations that can get more than one charge, you have to indicate the charge in parentheses using Roman numerals when you're writing the name. Bullet point 2, to determine the charge in parentheses, look at the anions. The cation charge must cancel the charges of the anions.
To determine charge.
On the metal, the charge.
The charge in parentheses.
Yeah, whatever you're going to put in parentheses. The charge on the cation. So once again, if I'm looking at something like this, FeCl3. Again, we need to determine the charge on that. So we have 3 chlorides. Each one's a -1. So that has to be a +3. It's just like doing a simple algebra thing. What you never do, and I've seen this happen, I'll give someone a name. Like I'll say, for example, write the formula for manganese 4 oxide. So, I'll write that on a quiz, and I'll get this. Mn4O2. That's wrong. You never, in a formula, you never put the parentheses. Just don't do it. It's only in the written name. The formula enables you to get the written name. So that's not so bad, I don't think. You guys have any questions about that at all? All right, we'll practice a couple more, and then you'll have your class meeting next period.